Today we're going to take a simple hard-coded ability system and using generic interfaces, we're going to refactor it into something flexible and powerful. We're going to separate abilities from the player and make effects reusable across any kind of target. We'll extend the system to handle effects that play out over time, and we'll make abilities composable. So a single spell or ability can apply multiple effects at once and can be managed cleanly through events and lifecycle hooks. Let's take a look. Let's start by having a look at the enemy class. Right now, this class is very simple. It just allows the enemy to take some damage, and if they take enough damage, it will actually destroy the game object. Nothing immediate to change here, although we might want to consider a rename. This looks more like a health component than an enemy component. If we come over to the other class in our system, Player Ability Caster, here's where we can see some obvious room for improvement. The main problems are that each ability is a custom method. We can't easily add new effects to the system, and our poison logic is tied to the player via a coroutine. So let's refactor this into something extensible. I've got a new file here where we can introduce our first generic interface. We'll call this interface IEffect, and it will give us two methods: apply, which will perform the effect on some target, and cancel, which lets us cleanly stop an effect if it's running. The reason for this interface is separation. Instead of the player deciding exactly what happens when casting, each effect now owns its own behavior. The player just triggers it. Next, let's have a serializable class we'll call damageable. This class will implement IEffect of type enemy. Inside, we'll add a public integer called damageamount. Then we can fill out the apply method. It takes an enemy target and simply calls take damage with our damageamount. Finally, we implement cancel. Since damage is a one-shot effect, there's nothing to cancel. So this method is just a no-op. We'll need it for the next method though, which will be for damage over time. There are lots of different ways to handle long-running events in Unity, but in this video, I'm going to use an extension of our existing improved timers class. Here we have a class called interval timer, which is a timer that runs for a set duration and it fires events at fixed intervals along the way. So it's perfect for things like poison, burning, or regeneration effects, basically anything that applies its impact over time. So let's see how we can use this to make a damage over time effect. So for our damage over time effect, let's mark this class as serializable so we can configure it in the inspector. This class is also going to implement IEffect of type enemy. Let's add some stubs for our two interface methods so we can get rid of that red squiggly. Then we'll give it three public fields: a duration, so how long the effect should last, a tick interval, so how often it should apply its effect, and the amount of damage we'd like to do every tick. Then we can add two private members. We'll have an interval timer to keep track of the ticking, and we can keep a reference to the current target. Now let's come down to our apply method and fill it out. The first thing we're going to do here is store the target that we're applying the effect to. Then we can create a new interval timer and pass in the duration and the tick interval. Then we're going to hook into two callbacks: on interval, which will run each time the timer ticks, and on timer stop, which runs when the timer finishes. Finally, we start the timer. Now let's fill in the callbacks. On interval checks if the target is still valid, and if so, calls the take damage method with the damage amount. Now, when the timer stops, we want to perform some cleanup, but we also want to do this from the cancel method. Now here, we could defensively make sure that if the timer exists, we stop it, but we also want to do our cleanup. The cleanup method is actually going to be quite simple. We'll just set the timer to be null, and we'll set our current target to be null as well. We can make this a little bit more robust in the future by just keeping the timer cached. Another thing to consider is that right now our effects are tied directly to enemy. That means if we wanted to apply damage to another object like a destructible barrel or even the player, we'd have to duplicate code. To fix this, let's add another interface we'll call IDamagable. It will have a single method, take damage, that accepts an integer. Any object that can take damage can implement this interface. In fact, let's go over to the enemy class and update it so that it implements IDamagable. We keep the same take damage method. Nothing's changed here. Now this class can be used wherever the interface is expected, not just where enemy is hard-coded. So now we can come back here, and in damage effect, where I was referencing an enemy, we can just replace that in two places with IDamagable. And in the damage over time effect, we're referencing the enemy type 3 times. In all cases, let's just replace it again with the interface. For multi-cursor, just Alt-click to select an entire word, Control-arrow. You can also remove an entire word with Control-delete or Control-backspace from your cursor position. Now, up to this point, we've been treating these effects as completely separate things. But what if we want an ability that has multiple effects? like a fireball that deals instant damage and applies a burn over time. We could keep all the effects we want to use in a list, and here I'm going to mark it as a serialized reference. You could just as easily implement this system with scriptable objects, especially if you want your abilities or effects to be reusable assets shared across multiple objects rather than tied to just a single serialized instance. Now let's add an execute method. This will take a target, loop through every effect in the list, and apply them one by one. Now an ability is nothing more than a collection of effects. Now I've cleaned out our ability caster class because it's going to be quite simple. Instead of having methods for specific effects, the player will have a collection of abilities. In update, we can loop over this hotbar. If the player presses 1, 2, 3, and so on, we can find an enemy and call execute on that ability. Now in the future, of course, we'll replace find first object by type with a real targeting system. And in fact, each ability might have its own unique targeting strategy. But this is a big milestone. By abstracting out abilities into a list of effects, we've achieved composition. Designers can now build complex abilities entirely out of data in the inspector, without touching the player script or writing any new code. So let's have a look at the component on my player. For my hotbar, I can add a new ability, and in each ability, I can start adding effects. Now I'm using Odin Inspector, which is why this looks nice. If you don't have Odin Inspector, you can watch this video that I'm going to link on the screen and learn how to make your own property drawer in about 5 minutes. So I've added a one-shot damage effect that apply 10 damage. Let's add one more that'll add damage over time. Let's change the duration to 3. We can keep tick interval every 1 second, but let's make the damage per tick something like 5. Now, of course, you can set this all through code. If this was a real hotbar, of course, you'd drag and drop and swap these out over time. But here, we can just add as many as we want. The serialized reference makes it really easy to test. In fact, we'll make this a little bit more robust in just a second. But for now, we want to make sure that our dot is working and that our one-shot damage is working as well. So let's Control P into play mode, and I'm just going to press 1. Right away, we see our one-shot damage hit, and every second we see 5 more damage being applied. Our enemy's health, which started at 50, is now down to 25. So far, our effects run, but there's no clear way to know when they've finished. That becomes a problem for ongoing effects like a poison effect. If the enemy dies, the poison might keep ticking. Or maybe the enemy has a way to cancel that effect on themselves. Maybe they have potions or something. To handle this, let's extend our interface with an event we can call onCompleted. Each effect can raise this event when it's finished so that whatever owns the effect can unsubscribe and clean up. In both of our implementations of the interface, damage effect and damage over time effect, let's add the event declaration. In our damage effect class, inside the apply method, after we've dealt damage, we can immediately raise onCompleted because it's a one-shot effect. But just in case somebody was to call the cancel method, we could also fire the event so that any cleanup that needs to happen will happen. Now we can just page down so we get a full view of damage over time effect. Here it's a little bit simpler because we already have a cleanup method. Anytime we're cleaning up our damage over time effect, we can just fire the onCompleted event. Now we can update the enemy so that it actually owns its effects. When we apply an effect, we can subscribe to its onCompleted event and add it to a list of active effects. Our take damage method might still be useful, but what we really want is to be able to add and remove effects from our list. When an effect is applied, we first need to subscribe to that onCompleted event, so we'll know when it finishes. Then we can add the effect to the list, and then finally we'll call apply on the effect, which passes this enemy in as the target. When an effect completes, we want to unsubscribe from the event and then remove the effect from our active list. Now we also want to make sure that when the enemy is destroyed, we can loop through every active effect, and for each one, we can first unsubscribe from its event, then we can call cancel to stop it cleanly. After all the effects are canceled, we can clear the list and destroy the enemy game object or return it to its object pool or whatever your system is. Now that enemies know how to own and clean up their effects, we can refactor the ability class to take advantage of that. Inside of execute, where we loop over every effect in the ability, we can say if the target is an enemy, we can call its apply effect method. For any other object that implements IDamagable, we could fall back to just calling apply directly. Of course, in your own project, if every damageable object is capable of handling effects, you could push apply effect up into the IDamagable interface. That way you could just call apply effect on whatever the target is. Now, your abilities and maybe your effects as well might want to keep more information. For example, we could associate every ability with some kind of cast sound effect and maybe a casting visual effect. And for the long-running ones,
we could have a long-running VFX. And you could keep other information as well. Perhaps you want to keep track of who cast this effect in the first place. If we come back to the ability caster class, we can coordinate all these effects in a new method we'll call cast. Here, we just execute the ability on the target. In update, instead of executing an ability right off the hotbar, we can pass that ability into the cast method. Now let's handle those effects. In the cast method, we get a reference to the target as a mono behavior. Now, if we've set a casting VFX and this target is a mono behavior, we can instantiate the casting VFX just above the enemy. If the ability has a running VFX, we can instantiate it as a child of the target so that it stays attached. Then we can destroy it after 3 seconds, but it would also be destroyed if the parent was destroyed. Finally, let's check for audio. If the ability has a cast SFX assigned, we can play it at the player's position using play clip at point. Let's jump back into Unity and see how this looks. I've already added some FX here, so we'll just go right into play mode and press 1. Okay, so we can still see our damage going off in the console. One more cast and we should wipe him out entirely. Now we can run a few more manual tests. What would happen, suppose, if the enemy had less hit points than 50? We should make sure that the timer stops. And of course, there are many other things we can do to make this system more robust, not the least of which is to start pooling these VFX. Instead of referencing them directly in the ability, we could think about injecting some kind of factory that would pull them out of an object pool. And of course, we need a targeting system, and we need to build the UI for the hotbar and so on. But that's all I've got for you today. Hit that bell because there'll be a new video at the same time next Sunday. And of course, join us on Discord if you feel so inclined. There's lots of other developers there just like you, answering questions and helping each other solve problems. So for now, I'll throw another video up on the screen. Maybe I'll see you there.